Alright, so for this chapter, chapter number 7, we're going to be looking at everything to do with algebraic division and trying to find factors and factorizing more higher expressions such as cubic expressions. So first things first, we're basically going to be dividing a polynomial. And I've written what a definition of a polynomial is. It's a finite expression with positive indices. So an example of a polynomial is, for example, x squared plus 2x, right? Because all the indices are all positive and they're integers, and there's a finite number, meaning there's a split. It doesn't go on for infinity. An expression which is not a polynomial is something like x minus 1 plus 3x squared, because you can see here this is not a positive indice, it's a minus 1, right? So we can't really divide this kind of stuff. So we're only going to be dividing polynomials. Right? And this method is called algebraic division, and it's just a series of steps which you just keep repeating until you finish dividing. So let's just look at an example. So let's say we want to divide 6x cubed plus 27x squared plus 14x plus 8, and we're dividing that by x plus 4. Okay, so this is a polynomial. I'm going to divide it by a linear expression. And so what we can say is, well, we can set it up by saying x plus 4 like this, like just in the long division form, which you guys might have learned in when you guys were younger. So this form here. Right, as I said, it's a series of steps which we're going to keep repeating. So the first step is we're going to look at this x and we're going to divide 6x squared by x, okay? And as you can see, if you just divide 6x squared by x, you get 6x, right? And importantly, we're going to write, so 6x cubed by x, we're going to get 6x squared, sorry. And importantly, we're going to write all the squared terms in the squared column. So this column here is the squared column. This column here is the x column, this column here is the x cubed column, this here is the numbers column, okay? So if it's, just make sure you write in this specific column. So as I said, 6x cubed divided by x is 6x squared, so I'm going to write that on the top here in the x squared column. So that's the first step. Next, I'm going to do minus and open my bracket. And I'm going to now multiply the 6x squared to each of these x, to each this one and this one here. So 6x squared times x is 6x cubed. 6x squared times 4 is plus 24x squared. I'm writing that in the x squared column as well. Okay, so just be careful you write it in the same column. And now it's subtracting. So 6x cubed minus 6x cubed is 0, so that'll cancel out. 27x squared minus 24x squared is 3x squared, like this. So that's the first step, okay? Or that's the step we're going to be taking and what we're going to be repeating. Next, we now bring down this 14x, so it's now going to be plus 14x like this. And now we repeat the whole process again. So what do? I now divide 3x squared by x, okay? Which will give me 3x, which I'm going to write, or plus 3x, which I'm going to write in the x column on the top. And then minus, open bracket, and same thing now. I look at this 3x and now I multiply it to each of these x's and the 4's. So I get 3x squared, 3x times 4 is plus 12x, close bracket, and then we subtract. So the x squares will cancel out, leaving me 2x, and now I bring down the final term, this 8, and this becomes plus 8 like this. And let me just repeat the process one final time. So we have 2x divided by x is plus 2, so I write in the number column on the top, minus open bracket, multiply 2 to each term, so you get 2x plus 8, and then close bracket and subtract, and you'll be left with 0. So this is the process of algebraic division. Okay, it's just a series of steps which you keep repeating until you finish, you get to the end. Right, so from here, what we can actually work out is a couple of terms. So this top term here, we call it the quotient. Okay, we call it the quotient. And the bottom value here, the final value, we call it the remainder. So importantly, if the remainder is 0, it means that this here, this initial one we were divided by, is actually a factor of the polynomial. If it's not 0, then we can deduce that it's not a factor of the polynomial. Okay, so if there's a remainder, it's not a factor. If there is no remainder, it's 0, then it is a factor. So this original equation here, which I was trying to divide, I can rewrite this as 6x squared plus 3x plus 2. Okay, so we divided it, and that's what the quotient is left with. Okay, so this process is just a matter of practice. It's not too difficult once you get the hang of it. So let's try another one here. Let's try 5x plus 3 And then we have 25x to the power 4 plus 75x cubed plus 6x squared minus 28x plus, let's do minus 6. So this is a bit longer, but the process still stands. So first things first, 25x to the power 4 divided by 5x is 25x cubed. So I'm going to write that in the cubic column, minus open bracket, multiply 5x cubed to each term. So we get 25x to the power 4, plus 5 times 3 is 15x cubed, close bracket, and then subtract. So power 4s will cancel out, and you'll be left with 60x cubed, and then I bring down the plus 6x squared. That's the first step, which I'm going to repeat. So 6x cubed divided by 5x, that will give me 12x squared, so plus 12x squared, minus open bracket 60x cubed, plus 12 times 3 is 36x squared, close bracket, and then subtract. So x cubed terms would disappear, we'll be left with minus 30x cubed, bring down the next term, minus 28x, and then repeat again. Minus 30x cubed divided by 5x is minus 6x squared, so don't forget a minus sign, so minus 6x, and then minus open bracket, multiplier, minus 30x squared, minus 18x, close bracket, and subtract. Minus 28 minus 18 will give me minus 10x, and then I bring down the final term, minus 6, and then do it one more time. So minus 10x divided by 5x is minus 2, minus 10x minus 6, and I get 0. So this 5x plus 3 is actually a factor of the original polynomial. Let's just try one more. So let's try maybe minus 3x cubed plus 50x minus 8 divided by x plus 5. Now, at first glance, it might be the same method, but it's just one thing that you should be aware of when dealing with this specific type of question. You would notice as we go from x cubed to x straight away, so there's no x squared term, okay? So this is very important when we're setting up the example. So same thing, we do x plus 5, and then we write out the polynomial, so minus 3x cubed, but there's no x squared term, right? But when we're doing this, we have to include the x squared term, and we do that by adding a 0x squared. Okay, so even though there's no x squared term, we have to include this term when doing the division. This is the same thing for all the top stuff. So if there's no like x term, then you have to include plus 0x. Okay, it's very, very important we include this. And then plus 50x minus 8. But once we have included this, then the steps are exactly the same as we've been doing before. So minus 3x cubed divided by x is minus 3x squared, minus 3x cubed, minus 15x squared, which will give me 15x squared. Bring down this one, so plus 50x. 15x squared divided by x is 15x, so minus 15x squared plus 75x, like this. And then what we have is 50 minus 25x, bring this down, minus 8. So with so this would be minus 25, so minus 25x. 25 times 5 is minus 125, like this. And as you can see, we'll get a remainder, right? Because minus 8 minus 125 is 117. So what we can see now is we have a quotient and we have a remainder value. And so what we can say is now x plus 5 is not a factor. Okay, so if I was to rewrite this initial one here, I'll have the quotient, so minus 3x squared plus 15x minus 25, plus the remainder over the denominator like this. So this is how I would rewrite it if there was, or if it was not a factor.